Data visualization, Heapmap using Python Seaborn package. In this lesson, we are going to learn how to plot heat maps using Python Seaborn library. Heapmap is a great tool for data visualization. A heat map is basically a plot of rectangular data as a color-encoded matrix. In this lesson, we will use data from a CSV file, from Seaborn package's flights dataset, and from a database. The first two are basically the same data but in different formats. Before proceeding further, let me write a few lines of codes for generating a heat map. I will discuss everything about it later. For the time being, just follow me along. After importing the required packages, a data frame is being created using a CSV file, data.csv. The CSV file has a column named month. We are using this column as the index of the data frame. Now our data frame is ready, let's plot a heat map using the Seaborn.Heatmap function. The only argument passed to the function is the data frame, df. Let's run the code and check the output. And here is our heat map. Isn't it interesting? We have plotted such a beautiful heat map with just a few lines of codes. We have already generated a heat map. Now let's see what data were used for generating this plot. The contents of the data.csv file is shown on the screen. I have prepared this data file from the flights dataset of the Seaborn library for demonstration purpose only. Here each row of data corresponds to the number of flights for a particular month in different years in the range of 1949 to 1960. That is, columns represent years and rows represent months. We have read this file using pandas read_csv file and created a data frame df. The data frame was passed to the Seaborn Heatmap function unaltered. That's all. So, if we have data in the right format, we can create heat maps with our eyes shut. But unfortunately, this is not the case always. We need to pre-process the data and rearrange the data in the right format before we can pass it to the heatmap function. Now we will plot a heat map using the flights dataset of the Seaborn library. So, first let's look into the dataset. First of all, let's load the flights dataset into a data frame, df, using the load_dataset function. Let's display the dataset. As we can see, the dataset has 144 rows and 3 columns. And the columns are year, month, and passengers. Now let's see what happens if we try to generate a heat map using this raw data frame. The heatmap function is unable to plot the data as it is not in the right format. We need to rearrange the data. Now we will use the pandas pivot function for converting the long format data frame df to a wide format data frame. The rows will be indexed by months, and the column will be the unique years, and the values will be the number of passengers corresponding to the month and year. Now our data frame, df, is a pivot table of the original data frame. Let's view the data. Can you find any similarity between the contents of the CSV file shown earlier and the contents of our data frame df? Yes, both are the same. I saved this data in a CSV file. Now our required data frame is ready, we can plot this data frame without any problem. Let's try. Now the heatmap function generates a heat map without facing any issue. How nice! Now let's explore a few additional parameters of the heatmap function. We may use the annotate parameter for annotation purpose. If true, the data value will be shown in each cell. As we can see, the values are in exponential format. We may format this with FMT parameter. Here FMT equals 0.0f indicates decimal number format, 0 place after the decimal point, that is whole number. Now the values are as per the supplied format. 0.1 indicates that one place will be considered after the decimal point. We may use the CMap, that is, color map, for changing the color of the heat map. We may use the vmin and vmax parameters for setting the minimum and maximum values, respectively. It will anchor the color map. The argument, square equals true, set the shapes of each cell as squares. Look, now each cell of the heat map is a square. C-bar equals false, removes the color bar from the plot. C, the heat map has no color bar. We may set widths of the lines separating the cells using HeLineWidths parameter. Here the line width is set to 1. We may also set the line color using the line color parameter. Heapmap is an axis level function. Let's assign this axis object to a variable, ax. Using the axis variable, ax, we may now set the title of the plot, set the x-axis and y-axis labels, position, the ticks, etc. Here we are removing the x-axis and y-axis labels by setting these two parameters to blank strings. Look, now our plot has a title, and the x-axis and y-axis labels no longer exists. We may format the title with additional parameters such as weight, size, etc. Now the title is bold and larger. Now let's position the x-axis ticks at the top side. Look, the ticks of the x-axis has moved from the bottom to the top. We have already covered most of the important parameters of the heatmap function. Now let's move to our last part, that is, generating heat maps using data from a database. In this example, we will use the database, data science, and the table transaction from this database. The columns of the table are as described here. This is a demo table, so it has only a few important columns. In actual applications, this table should have many other columns. Let's display few records from the transaction table. These records will give you some idea about the values in various columns or fields. As we can see, the transaction_date field is actually a date-time field. As we can see, the table has nearly 1.7 million records. So, our data resides in a database. In this example, we will access the database directly from our Python code, rearrange the data in the required format, and finally we will plot a heat map. So, let's begin once again. We will use the pandas and SQL Alchemy packages here, so we are importing these packages. It is not necessary that we need the help of SQL Alchemy only for accessing databases. We may use other libraries too. Our goal is to access the database and create a pandas data frame. You may view other lessons for database access techniques. Links are provided in the description. Creating a database engine object using the connection string defined above. Now we can use the engine object to send a query to the database and retrieve the result. Here's our SQL query for fetching the required data. This is a very powerful query. It will search the entire transaction table with nearly 1.7 million records and prepare month-wise transaction count for each year. This is our complete SQL query. We are passing this query to the SQL Alchemy engine object with the help of pandas read_SQL_query function. Let's view the result. For the time being, let's disable the codes below using commenting technique. And here is the result. We have successfully retrieved results from the MySQL database. See, each row of the result is for a particular month of a particular year. That is, the result is in a long format. Now let's convert the data frame df to a wide format using pandas pivot function. Now let's convert the number of transactions to number of thousand transactions and also round it off to 2 decimal places. Oh no! I have forgot to provide an alias, trns here. Let's correct it. And here is our final data frame that can be passed to the Heapmap function. The data for a particular year is in a single row. The columns are for different months. Let's pass the data frame to the Heapmap function. Just removing the commenting quotes for enabling our earlier written codes. This is our final code. Let's modify the title of the plot. Now, finally, let's run the code. And here is our beautiful heat map. The top left cell is blank as we have no data for January 2006. I do hope that you have learned something from this lesson and enjoyed it. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.